Hello everybody. In this video we are going to be looking at the solutions to the college prep refraction due right now, number 1. Light has a speed of 2.00 times 10 to the 8th meters per second in clear acrylic. The first thing I want us to do is find the index of refraction of the clear acrylic. So I know that the velocity or the speed of the light wave in the acrylic is 2.00 times 10 to the 8th meters per second. I know that my speed of light in a vacuum is 3.00 times 10 to the 8th meters per second. And we are trying to find the index of refraction. I know the index of refraction is equal to C divided by V, or the speed of light in a vacuum divided by the speed of the light wave in the medium. So 3.00 times 10 to the 8th meters per second divided by 2.00 times 10 to the 8th meters per second will give me an index of refraction of 1.50. And remember that my index of refraction does not have any unit attached to it because we are simply taking meters per second, dividing it by meters per second, which cancels out all of my units. Dimensional analysis right up to the very end. Love it. Part B says a beam of light traveling through air strikes a block of clear acrylic at an angle of 29 degrees to the normal. At what angle does the light enter the block of clear acrylic? So my angle of incidence for the light ray, this is as it's still traveling through the air, is 29 degrees. So that is theta 1. Because it's traveling through air, initially, I know that the index of refraction is going to be 1, or the index of refraction for air is going to be 1.00. The index of refraction for the acrylic, which I got in part A of the problem, is 1.50. And to find the angle of refraction, or the angle that the light wave enters the block in, and remember we always measure that from the normal, I need to use Snell's law. So I know that the index of refraction for my incident medium times the sine of my angle of incidence equals the index of refraction for my refracted medium times the sine of my angle of refraction. Now, if I want to solve this for theta 2, or my angle of refraction, I need to, first of all, divide both sides by n2, and that will give me this. And then I would have sine theta 2 equals n1 sine theta 1 divided by n2, and then I just need to take the inverse sine of both sides to isolate theta 2. Now I plug my known values into that equation, and I'm going to get an angle of refraction of 18.9 degrees. And remember, make sure that you have your calculators set to degree mode and not radian mode so that you don't get funky answers when you use the trig functions.